Example 1, find the inverse of the relation shown below. This is quite easy to do if you follow the direction that was given or the definition that was given above, where inverse is a relation where the domain and range become switched. So to find the inverse of this relation, we simply switch the domain and range, which means we just switch the x's and the y's. So all the points just get flipped. The first point will become -1, 0. The second point would become 0, 2. Third point would become 2, 3. And the fourth point would become 3, 4. And that is our inverse function. Now, what if the equation or the relation is in y equals form? How would we find the inverse function of that? Since the domain and range switch, to find an inverse function, what we would simply do is, well, literally switch the x and the y in the equation. No numbers, just the letter x and the letter y get switched. And then what we'll do is, because we like to have our equations in y equals form, we'll solve for y again, and that will result in our inverse function. Let's try an example. Example 2, find the equations for the inverses of the given functions, complete I/O tables. We're probably just going to complete one point in each I/O table so that you can see what an inverse function does. Well, let's see, you're given the equation y equals 2x plus 4. You are asked to find the inverse equation, the equation that will switch the domain and range. Well, the direction above says to simply switch the x and the y in the equation. Just the letters, no numbers. So y equals 2x plus 4 would become x equals 2y plus 4. So we have just created an inverse function. We typically like our equations to be y equals, so what we will do is solve for y and put it back in slope-intercept form. So what we would do is we would take away 4, take away 4. That would result in x minus 4 equals 2y. Then I would finish it off by dividing by 2. And the result would be y equals 1/2 x minus 2. And that should be the inverse of y equals 2x plus 4, but let's test that out. In the equation y equals 2x plus 4, we're not going to complete an entire I/O table. I'm just going to ask you to pick a number, any number, and put it in the x column. I'm thinking of a number 4. You don't have to pick 4. What I want you to do is substitute that into 2x plus 4. For me, I would get 2 times 4 is 8. 8 plus 4 is 12. So there's a point on the line y equals 2x plus 4. Next thing I'd like you to do, take the output, or the 12, and make that the input for your inverse function. Substitute that in and see what happens. Well, I would get 1/2 x would become 1/2 12, or 6 minus 2. What do you notice? You get the x value from above. The equation that we produced, y equals 1/2 x minus 2, flipped the domain and range. What I'd like you to do now is to pause the video, try the second example, y equals -3x plus 6, and then restart the video and watch the solution. Y equals -3x plus 6. We will begin by switching the x and the y, just the letters, not the numbers. X equals -3y plus 6. Then we would solve for y to get it back in our slope-intercept form. Let's see, we would begin by taking away 6. And the result would be x minus 6 equals -3y. Go through and divide by -3. And the result would be y equals, we would end up with -1/3 x plus 2. A negative divided by a negative is a positive. Now let's verify that this is in fact the inverse. In our above equation, y equals -3x plus 6, I'm going to ask you to just pick an x value, any one you want. I'm going to pick, let's say, 3. You don't have to pick 3. Let's see, so I would substitute in -3 times 3 is -9, plus 6 is -3. And then I'm going to take the output, or the -3, and make that the input of my inverse, and see what I get, see what we notice. Well, if I substitute -3 in for x, I get -1/3 times -3, which will be -1 plus 2, and I get 3, which, if you notice, was the x value in our original equation. Therefore, they are inverses.